everyone. Okay, section 2.6, proving angles congruent. Actually, we prove angles congruent. We use angles that we know are congruent to find other things out. We're still throwing in some linear pairs because we'll continue to use those. So it's a little bit of a mishmash of using relationships still to solve for variables, find angle measures, and we're going to do one last proof as well. So here I have this figure that I was given, just two intersecting lines marked, this angle is 2x, this angle is marked as 5y plus 4, and this angle is marked as 76 degrees. So what I have to do first is I have to find some kind of a relationship because it's all about setting up an equation if I have to solve for a variable. The key is I might have a lot of relationships to choose from, so I have to choose a relationship that enables me to set up an equation that only uses one variable. I could do a linear system, which we threw in a little bit of practice for that since it does kind of technically go with a section, but really I probably don't always have to, at least in the examples that we're going to be doing. So anyway, when I looked at this, and again, it's just me, the first thing that tends to catch my eye is vertical angles. So I looked at this, I saw these vertical angles right here. Sometimes people call them, again, bow tie angles because they're, look like a little bow tie. And since I know that vertical angles are congruent, it makes it very easy for me to set up that equation. I know that if this angle is congruent to this angle here, then 2x equals 76. I divide both sides by 2 and I get x equals 38. I also have actually two sets of linear pairs. The one I'm going to use is this set here. And again, if you ever wonder if you have a linear pair, you should be able to include both angles in a semicircle because both a linear pair and a semicircle are 180 degrees. I do have a linear pair here also, but that would enable me to set up an equation that has two different variables, which I'm not going to get very far with that. So I'm looking for the pair where I could only use one variable. So I know that this angle here, which is 5y plus 4, plus this angle here, which is 76 degrees, that's my linear pair, so those angles together equal 180 degrees. And that's my equation that I set up. I just solve it from there, and I get y equals 20. This did not ask for angle measures specifically, but if you had to find them, it would be just about, substituting in the values for the variables. But that's also how I like to check. So I can check by substituting the values in and seeing if the relationships actually work. Well, when I substituted 38 in for x, I got 76, which I should because these two angles are congruent. And when I substituted in 20 for y, and I figured that out, I got 104. Well, and if this is my linear pair that's supposed to equal 180 degrees, then 104 plus 76 does equal 180. So there was one example. This example obviously looks very similar, but we have one more variable thrown in there. So how I'm actually going to set this up really doesn't change very much, but when I look at all of my different relationships, I have two sets of vertical angles, I have linear pairs all over the place. When I look at all of the different combinations on this one, really my only starting point was with these vertical angles here, because that's the only relationship I could set up where my equation would just have one variable. Everything else I would look at, these two vertical angles, I would actually have three variables. This linear pair, I would have two variables. This linear pair, I would have two variables. This one, I would have two variables. And this one, I would have two variables. So these vertical angles were my starting point. I know that 5y minus 20 equals 3y plus 8. And I solve, and I get y equals 14. Again, I think it's important in these to eliminate as many variables as you can and start giving yourself actual numbers to work with. So once I solved for y, I kind of plugged it in everywhere I saw the letter y, just to start simplifying a little bit. So I got this angle to be 50 degrees and that angle to be 50 degrees. This up here, 70 plus 4x, because I could substitute in for y, but I don't know x yet. Now I'm going to look for a relationship that actually is an equation that I could set up. Well, if I'm solving for x, then x is a part of this linear pair and this linear pair. It didn't really matter which one I started with because this angle's 50 no matter what. So let's just look at this angle pair here. I know that this angle, which is 50, plus this angle, which is 70 plus 4x equals 180, because that's my straight line there, my linear pair. I solved for x, and I got 15. Now, I still have to justify how I'm getting z. So I could look at this, 70 plus 4x, substitute in 15, and get 70 plus 60, which is 130, knowing that z is a vertical angle to this. So this was the idea of using these vertical angles to figure out the measure of z. So I'll mark that down, vertical angles. Or I've got a linear pair here too. Well, if this piece of the linear pair is 50, then this has to be 130. Okay, so I've got vertical angles. Oh, and I wrote it down here. And I've got z equals 130. This would be because of a linear pair. Okay, I would know that 50 plus z equals 180. Okay, so again, this was my only starting point on that, but once I solved for this variable, I plugged it in everywhere, and then I just started looking still, where do I have vertical angles? Where do I have linear pairs? Again, you might come up with this somewhere along the line, so make sure you ask a question if you need to. And then the last page here is just using some of these to do another little bit of a proof. So I have these three angles here, and two of them are marked with some kind of an expression. This one is not, and I'm given that angle SMH is congruent to angle TMI, and angle OMG is congruent to angle TMI, and I am supposed to prove that x equals 15. So again, the first thing I write down is my givens exactly the way that they're given, and the reason I can say that is because they were given. So I have to, again, figure out, okay, well, where do I go from these givens? Well, I could look at this actually in two different ways. I could say that angle SMH is congruent to angle OMG through either substitution or the transitive property. Okay, they're both kind of congruent to the same thing. So in a way, they're sort of equal. So I substituted, or I could think, you know, if SMH is congruent to TMI and OMG is congruent to TMI, then SMH is congruent to OMG. Okay, so again, this one's a little bit trickier because it's congruency, but I still think technically either one of those would be okay. Once I know they're congruent, then I know that their measures are the same. So this is actually an important step, even though it seems pretty obvious. So if they're congruent, the measurements are the same because that's the definition of congruent angles. Once I know this relationship here, that angle SMH is equal to angle OMG, then I can substitute in the expressions that I was actually given. So I'm saying 4x minus 35 equals x plus 10 because of substitution. Then again, it's just algebra. So how I got from this step to this step was I subtracted x from both sides. That's how I get from 4x minus 35 equals x plus 10 to 3x minus 35 equals 10. subtraction property of equality. Then I got from this step to this step by adding 35 to each side. So the reason I could say 3x equals 45 is because of the addition property of equality. I wouldn't have wanted to do both of these in one step. Like if I were actually solving this equation, I probably could have brought my x this way, brought my 35 that way, and gotten to here all in one step. But because I had two different properties involved, I had to separate out those steps. And then lastly, how I get from 3x equals 45 to x equals 15 is by dividing both sides by 3, and that's why my reason is the division property of equality. And I have proven what I was supposed to, so I am done. So again, please ask as many questions as you need to, and we will see you around. Bye.